Okay, welcome to our gerontology research group online meeting. It is Saturday, April 24th, 2021. This meeting is put on in part with the great efforts and great thanks to Miles Jacobs. He is living in, I believe, the great country of South Africa and joined our group recently. We're an international crew. He has taken the initiative to just set up these meetings, to set up proposed agendas, and I expanded a few agenda points. So Miles, thank you very much. We owe a great amount of thanks to you for our being here today. And let's just take a look at, oh, Jeff's in the waiting room there. I clicked admit. Okay, some of the agenda items we had in mind. Well, just a real quick background about me. I'm normally in Southern California, but now living in Boca Raton, Florida, working with a group down here to solve the problem of aging. And, you know, that's what, like many of you, that's the main focus in life, which has kind of put me behind the 8 ball in putting together these meetings and as many informative GRG posts. And that's where, again, thanks to Miles Jacobs for orchestrating this. Okay, the main category of a first topic of discussion that Miles suggested was under the category of towards open-ended healthy lifespan. And, you know, that open-ended part, what the heck? Shoot for the moon. You know, we're all in this because we love life, give us more. So in my estimation, the number one topic is resetting the epigenome or partial reprogramming with Yamanaka factors and others to reset the epigenome to a more youthful state. And I'm among the believers that will directly influence phenotype and will give us a lot more healthy years. I think of a couple of icons in the field doing research now. One is Juan Carlos Belmonte out in the West Coast at Scripps. And not only Belmonte, but a number of the researchers in his lab are dedicated. And if you want, I could put in the chat some of their names and some information about them. When the time is right, I have in mind to contact not only Belmonte, but the others in his group. And this will take money. That's one missing component. And also a certain amount of strategy and planning to facilitate, perhaps even set up a separate lab so that we can really advance their research. And it may not, or it may work with other clinics with human subjects, myself included, either here in the US or in locations in outside countries, just not too far from the US. But also there's a guy, I forget his first name, named Goya. I believe he's in either in the Caribbean or South America. Rudolfo.
Johnny, that's Rudolf Goya, and he's in Argentina.
Ah, good. Thank you. Argentina. Excellent. So having sort of set the stage, you guys know an awful lot about this. I would like to turn the floor over to you, to your topic with, you know, I'm going to suggest I would rather than a lot of theory, a lot of, you know, a lot of talk, I'd like to ask for specific action items. What's it going to take to turn their work into reality, into a therapy that'll get us into the next decade or the next century? Go ahead. take it. Someone had something to say. Please carry on. Or Miles, did you have some thoughts on how we're going to do that?
No, I think it was Robert who talked. Robert, did you say something?
Hello?
Hi, Robert. We hear you.
Yeah, so who was asking a question?
Well, I was asking how we're going to make it happen, is the short story.
Well, I think that, one of the things I do like, with the GRG approach for over 30 years is that you get the experts together and across multiple fields, doctors, we need both theory and application together. And, in the past, everything was kind of separated into everybody's own areas of expertise. And, one area of expertise, wasn't being, synced with the other areas of expertise. So, one of the things the GRG is doing is we're trying to get input across the spectrum. Aging is a problem that affects, every organ system in the body, every cell in the body. If we don't die prematurely, aging begins biologically approximately around age 27, although it starts to express itself mostly in the early 30s. That's why we see athletes are beginning to decline and deteriorate in their abilities even in their 30s. So this is a process that occurs over a very long period of time. And as we see at the highest stages, that biologically speaking, many of the people that are dying at the highest stages very, very closely aligned with the idea that the maximum human lifespan appears to be controlled by biology. We had 16 consecutive cohort years go extinct in a row. That would not happen by random chance. For that to occur, this suggests that there's some type of biological time clock that is ticking. We see mammal species such as mouse. We can't get a mus musculus to live to 5 years, no matter what. Yet elephants and chimps can, live to, 70 or more. So we do realize that the biology of aging is delimited by the species-specific lifespan. And although the lifespans of primitive species such as worms, fruit flies, and yeast have been extended, no scientist has yet successfully really extended the lifespan of any higher order organism. Some papers do claim lifespan, but they're actually misusing the term. What they're really talking about is life expectancy increase. When the maximum ages aren't changing or going up extremely slowly. Right now the maximum ages are going up basically because the population base is increasing, the amount of data coverage is increasing. That's just increasing the odds that we're going to see a higher expression of the data, but the data points really aren't showing yet, much of a real increase. We do see life expectancy increase, also feeling a little bit of a rise, but the rise has been very slow in over a long period of time. We had a maximum verified authenticated age of 108 in 1837, 110 in 1898, 113 in 1928, 122 in 1997. So when you look at that time period, over 160 years, the maximum observed lifespan increased 14 years in 160 years. That's less than 1 year increase per decade. That's not a good rate. So when we have to see it that way, we realize that, all the work and all the progress that's been made has mostly increased life expectancy. Life expectancy has increased over 30 years, but lifespan has increased less than 15. So I really think that suggests that we need to shift some of our focus away from application and treatment of problems after they occur. And we need to refocus a little bit more on trying to get people when they're healthy and before the aging problem becomes too great, that we can mitigate the factors of aging, or we can, in some cases, we might be able to reverse aging. We do know that, like a starfish, if it loses an arm, it can regenerate a new arm. Humans have a very limited ability for regeneration. If we lose an arm, we can't grow a new one. So we're not designed for much regenerative capacity. So these are issues. Is there any way in the future for us to be able to change the human genome in such a way that we can have a better ability to regenerate within ourselves? And I think these are some of the type of ideas that would be good for what the GRG is doing in terms of trying to figure out how we can extend the human lifespan through the application of treatment methods that real people are going to be taking.
Yeah, let me jump in and introduce Robert a little bit. He doesn't often post to GRG, and most of you, particularly the new members who have joined us, haven't met him. Robert is, in my estimation, and in that of many others, the world's authority on the world's oldest humans. And in terms of locating, categorizing them, validating that they are, in fact, what they say they are. So, and then maintaining the Centenarian database. And you may have noticed an email I sent out about 20 minutes before our meeting with an appeal for just very, very small amounts of money. They would all go to Robert's group to cover things like documents and shipping costs and costs that he and his team, and occasionally me, personally foot the bill. But I recall, well, it must have been almost 20 years ago, Robert, or at least 18, there was an initiative involving the Centenarian Research Foundation that Robert and I were involved in, where blood samples of people 110 years and older were taken, and it was sent up to Stanford and analyzed, and a paper was written. Now, this was admittedly the first pass or the first such initiative of its type, and they did a gene sequencing, trying to find a magic bullet gene that kept them alive for so long, and in earlier years, healthier, presumably, than their others in their age group. Unfortunately, they didn't find such a gene. So where I'm going with this is, if any of you are interested in championing, leading, facilitating some kind of initiative to revitalize something like that, knowing what we know today, and get Robert involved and others involved to do samples or some sort of analysis leading to potential aging solutions. That's the endpoint we would have in mind. We'll just contact Robert and me, and we will see what we can do to make that happen. So now we have more people joining us, and as mentioned earlier, you are not required to show ID, but I do need to know at least your name and maybe just a little bit about your interest and what you want to accomplish. So someone on an iPhone joined us. So please unmute yourself and just give us your name and just one sentence, what brings you here and what you want to make happen.
Sorry, I'm just eating.
Oh, you're eating, okay.
It's Paul. I'm Paul Harris, and I'm doing some mixed research on different things, but yeah,
Paul.
into it. Yeah, hi.
Oh, okay, welcome.
Hi.
Yes, Paul.
Yeah.
Paul is,
Maybe later.
I guess the word is esteemed member of our group, a high-level researcher, been, I seem to recall, with GRG a very long time. So thank you. I saw somewhere that two people raised their hands. So why don't you just, if you must have questions, so I don't see anything in the chat.
I
But-
think Miles raised his hands first, so maybe we could let Miles.
Oh, there
talk,
you are.
and then I was.
No, I think Robert, sorry, you wanted to say something based upon what you said before. Let's first finish that one.
Okay, yes. So basically, the Centenarian Research Foundation, was founded in 2004 with the idea that we would, collect biological samples from Centenarians and try to figure out, what is the biological reasons that people, aren't able to live beyond a certain point. And I'm going to say this is I think that a lot of people, including, Johnny Adams, Dr. Coles, Stan Primer, and others, and put in a lot of effort for this. But unfortunately, Dr. Coles got cancer and he passed away in 2014. And, due to the fact that the project was underfunded, we really didn't get very far. I think they only collected samples from 48 persons, and they really didn't get to the stage of actually doing anything with the samples. So the reality of it, I don't think we can say nothing was found when we hadn't even basically got very far with the investigation, and unfortunately didn't go anywhere since Dr. Coles died. But I do think this is something that needs to be done in the future if proper funding is secured, because we know based on the data that the Centenarian data is showing that the maximum human lifespan is delineated according to the species-specific limits. And we know that it's different. The oldest dog was 29. The oldest cat was like 39. Humans are getting to 122. Whales are getting to 200 plus. So the interesting thing here is, a whale is basically, in some ways over 90% similar to a human. But what is it that allows whales to live so much longer than humans? These are things that have never been studied before. Never, okay? We had one whale where they did a study where they tried to analyze the age of the harpoon that was stuck in the whale, but they've never actually tried to, figure out, why whales are living so much longer than humans. And is there some way for humans to live longer? So I think these are areas where there's so much potential that has not been reached yet. And, one of the ideas here with Plan A is to get the data better presented. Right now the GRG website was founded in 1995, and it's very lovely 1995 technology. And I'm just basically seeing it as that if we could come up with more funding for the presentation of the data, that for some people seeing is believing. If some people, we have a lot more data behind the scenes than is actually expressing on the website. The website is bulky, it's slow, it's cumbersome to try to manually put in a lot of information, using the old codes, and then we have, data crashes, and that slows everything down. So, one of the ideas for funding is if we can upgrade the system to operate faster, we can get the data processed faster. Right now we have over 1,000 case backlog on cases. And when people see the data is more sharply presented with more modern updated software, with more modern updated presentation, then I think the case is going to be even stronger that yes, there's a biological factor here. In fact, it's probably the most important factor. We find that environment has some minor effect on how long people live, but ultimately how long people live is really mostly down to biology. And the fact that we don't have the answer yet, because we've barely scratched the surface of the study on this, really indicates there's enormous opportunities here, potential for research in the future that have not yet been studied on this. So,
Yeah. John Winker has a question.
Yeah, I had a question and a couple of comments. I was just wondering if those samples still exist. Are they still in a freezer somewhere, or were they processed and then discarded? And the other thought is, I guess, is it doesn't really matter because we could all give samples. There should be no shortage of.
You're not 110, samples. Sir.
Pardon?
You're not 160.
Oh, I see. You're saying the rarity of those people. Yeah.
Well,
I kind of like the I kind of like the idea of Josh Middledorf. I think that there probably is something that's been, I actually think it may have been put in, inserted into the genome to keep humans from getting very old, because if you keep them from getting as old as corporations, then they lose the ability of the fictional character of the Highlander to learn and learn and learn and learn, and ultimately take control of their own destinies. So it's been suggested by those in the science fiction field that that humans were actually manufactured by aliens, starting with animal DNA, and manufactured for various purposes. And we don't have any evidence on this, either pro or con in this regard. But the existence of animals that do live far longer than humans, turtles, I think, might go to 500 years or something, in the hundreds of years, tells me that it's hard to believe that there's something that's intrinsic to turtles that couldn't be put into humans, or alternatively, maybe something in humans that couldn't be taken out of us to make us be like turtles with regard to having that capability. Similarly, with research in limb regeneration, I believe it's a salamander, or maybe it's a newt or something. You can regrow them. But humans don't do that very well at all. And so I think that the world is wide open with regard to the removal of barriers to regrow limbs and to just live forever. So this research needs to be done. So anyhow, those are just a couple of quick comments I had.
Well,
to the whole thing there.
I would look forward to any and all specific plans to make that happen. Now, two members asked.
You're right. It all requires money to do that. Proposals are easy to write, but getting them to be funded is a harder one. So I'm thinking about that.
Well, the funding plan is part of the comprehensive plan. So yeah. But well, here, if you can create a plan that presents evidence that will convince people with money that this will work, and that it will not only benefit humanity, but will help them and us live a whole heck of a lot longer, the money will happen. So now I see two members asked if the supercentenarian samples are still around. They are there. To my knowledge, there are 2, maybe 3 groups or individuals that still have them stored at minus 80 degrees. So I'll just suggest, if you have a plan on what to analyze, how to analyze them, and an end result of how, not just how it will result in useful contributions to science, but how that information could be used to create a therapy to help us live a lot longer. Please send that information my way, and we'll put it in the hands of people who are scientifically capable of evaluating it, and we'd love to move, to advance on that plan. So the first proposed, and there's nothing cast in stone here, but the first proposed topic was resetting the epigenome to a more youthful state and partial reprogramming, Yamanaka factors and others. And is there anything more to be said about that topic? I know we.
Yes, Johnny. Let me proceed. I need to. I've got a bit of a presentation, not a really long one, not a PowerPoint. It's certain points which must be remembered. I think people might remember I said in the past that in order to understand aging, you have to understand what the genome is doing the activities of the genome. And there are 3 activities in the genome which stand out, which is kind of the backbone of the genome. The one is the formation of the initial ball of cells, which is done by what is known as an attractor. Waddington studied this in the 1900s. It's an attractor which basically makes the trunk of the body, and divides the body up into segments. In the case of humans, those segments are the ribs of your rib cage. That's your segments. And the second system, which is there, is the identity of the different sections of the body. The different segments get an identity, which is done via the Hox complex. The Hox complex. We need to understand the Hox complex to understand aging. And then the last section of the genome, which is interesting, which we also need to understand, and that's the identity or the way that the appendages is grown. Various branching structures you see, and that's what we call a Lindenmayer systems. Lindenmayer systems, which was first identified by Aristide Lindenmayer at the University of Louvain. He was a biologist there. So those 3 systems, basically the Lindenmayer system creates things like your hand. The attractor creates your trunk and the segments, or your ribs. And then the Hox complex determines the identity of the different sections of your body, from your head to your toes. But importantly, the Hox complex also determines the biochemical dynamics. It determines the biochemical identity of each cell. And that is why the Hox complex, when we talk targeting complex, people need to understand that partial reprogramming of cells is targeting the Hox complex. Is it difficult? Okay, let me, Robert asked me to type out the different systems. The first system is the attractor. I can actually call it the Waddington attractor. Waddington attractor, you'll find Waddington's name all over this. For the segments, your segments, for segments, or for your ribs. For segments or ribs. The Hox complex for identity of your different parts of your body, Hox complex, and the Lindenmayer system, Lindenmayer system. So I've typed that out in the chat. I've typed it out. So Waddington attractor determines your ribs. The Hox complex determines the identity, for example, of your head, your toes, and so forth. And then the Lindenmayer system determines the branching structures, which you see, like your fingers. That is what the genome is using, what the genome is using to make you. And the partial reprogramming, because the Hox complex also determines the biochemical identity of the cells, the partial reprogramming is targeted to the Hox complex. The partial reprogramming with the Yamanaka factors is targeted to the Hox complex. And I want to show a diagram which is critical, because I think this diagram is actually the very core of every organism. It's how the very core of what an organism, how it retains its identity, and also how the cells in the body retain their identity. So I want to share one slide quickly. I was going to share my screen with one slide, and it's this one. Basically, you are looking at the longitudinal section as obviously a section of DNA. It's a gene. You will notice that we have here. These are the Hox genes. They are being regulated by the polycomb and trithorax proteins, which is these are repressors and attractors. So these are epigenetic structures. And they determine the identity then of a particular cell, including its biochemical identity. They are being helped by what is known as the terra RNAs, which comes from the telomeres. And this whole system, which is the regulation of the Hox complex, is then targeted and can be controlled by the Yamanaka factors. So this is critical to understand. I mean, we're not going to really progress without understanding the mechanics of how partial reprogramming actually works. So there is actually a very nice video on the internet, on YouTube, which explains how they've used the Yamanaka factors to reduce the ages of mice, to help with the repair of damaged structure in the mouse's body. And you can watch that video. I'll put the link there. But the point is the partial reprogramming is targeting precisely this system which you're seeing on your screen, what we call the OSK factors, the OCT4, SOX2, KLF4 factors. And these four factors, Mike, these four factors affect different parts of the HOX regulation, the HOX epigenetic regulation. For example, KLF4 affects the enhancers. SOX is basically controlling the effort or the effects of the polycomb and trithorax repressors and activators, and then OCT4 controls the TERA RNA. So the regulation of the HOX complex is the key to understanding aging. That's what I wanted to say. It's a lot of, you need to follow up a lot. Obviously, you need to read some papers about this, but there's also a very nice video on YouTube, which I'm going to put the link to, for you to understand how the partial reprogramming is used to reduce the aging, the epigenetic aging, in fact, the biomarker aging of organisms. Thank you very much.
Outstanding. Thank you, Miles. Looking for that in chat. Is anyone having difficulty locating the chat and getting it to display? Okay, there it is. Thanks. And I will put it in my notes. Well, Miles, would you, I knew you had studied a lot of things and you have your own methodology, or maybe it's more of a theory of how aging works and what you would do about it, but would you be qualified to lead or manage an initiative that turned this into something we could use?
Yes, Johnny, I believe aging is to do with the dissociation factors of the epigenome, epigenome proteins. In different species, they have different dissociation factors, so they have different time constants, and that ultimately determines the aging for a particular species. So if Robert is looking for something that can predict the age of a particular species, Robert, you have to look, I believe, it's my own personal theory, but I believe it's the correct one. You need to look at the dissociation proteins of the epigenome. There's lots of proteins which regulate the genes. They're called epigenomic proteins or epigenome proteins. Those proteins have dissociation factors over time, and that's what leads to this dissociation of that we see with aging. However, with the partial reprogramming with the Yamanaka factors, we are able to reset the programming so we can make it start again, basically by removing one by one the layers of the epigenomic control, because epigenomic control is not just one layer, there's several layers on top of each other. There's fundamental layers and there are more peripheral layers. So if we remove the more peripheral layers, we allow the genome to reset its own control, and that gives you a younger epigenome system or epigenome complex. So I think, Robert, you need to look at that. And Robert, also, I think looking at the video, maybe you should contact, I'm not quite sure how to pronounce his first name, Yongchen Liu, in the video, because they actually doing research with Dr. Sinclair on resetting the different levels of the epigenome. So they would have a lot of detailed knowledge of how this could work. That's my feeling is.
Yeah, well, Miles, what would be the next 3 steps or the next 3 things we would need to do to get on the roadway to turn this into a therapy that will keep us young?
I think, Johnny, that Turn.bio, they have some work in this Turn.bio because they use the Yamanaka factors. Also the Sinclair lab. I'm thinking that what Sinclair is doing, Dr. Sinclair or Professor Sinclair, it's very similar to what happened with those Russian biohackers. They took the work of the convoys and they performed it on themselves.
Right.
Uh-huh.
So I think that we're very ripe for somebody is going to start looking at performing the partial reprogramming on themselves.
record.
That's what I think. That's what's going to start happening. Because the effects, especially with
0.98
only the
years.
3 factors, is actually quite safe. It appears to be quite safe. So yeah, that's the first thing. I think there's going to be some biohackers, hackers, and then we need to have clinical trials which have to be funded. That's the next 2 steps: biohackers and clinical trials.
Yeah. So are you saying the Russian biohackers reset the epigenome?
They did that partially with the parabiosis, but they did not do it in the fundamental way that Dr. Sinclair is doing it.
Okay.
That is a start on the very peripheral parts of the epigenome, and also washing out the effects of some of the proteins that are accumulated. But there's a much more fundamental way which will have to be implemented now. So what they've done is fairly safe. It's a very simple procedure. But as you go down the regulation layers, they become more and more fundamental. And at the very bottom of the regulation layers is c-MYC. c-MYC resets the epigenome completely, creates a pluripotent cell, a potent cell, and in fact creates a teratoma, which is a cancer, which is actually just a new embryo growing in your own body. So there's layers of regulation of the epigenome. Those Russians have done the most top and the most sort of non-critical layers, but we have to proceed down to the more fundamental layers. And I think it's probably going to be, as Dr. Sinclair has shown, 1 step from c-MYC, which is the cancer-inducing layer.
1 step from what?
c-MYC. c-MYC is the 4th Yamanaka factor, which everybody tries to avoid, because that one resets the genome completely into an embryonic state. And if it's done in a living human, it creates a teratoma cancer, which is a kind of an embryo growing inside you. So Johnny, I mean, the process, we can actually start discussing this. I mean, I think those Russian hackers showed very nicely. We can actually start discussing what we can do, and it's basically hackers followed by clinical trials with funding for those clinical trials.
When you say clinical trials, to me, that means humans, of course. Are you saying that now Sinclair and Turn Bio are either conducting clinical trials or have a process or a therapy that they're ready to start trials?
Turn Bio is starting on sections of epigenome regulation. If you look at their website, they're doing OSK, they're doing the Yamanaka factors, but it's not full body, it's sections of the body. I think that's where we are at. We're going to start on sections of the body, but we're not going to start very deep. You have to be very careful, because like I said, the lowest level creates a cancer. But the other levels reset the cells to a youthful, in fact, they reset the cells to the age of 25, which is very interesting. It's because we know that aging starts at 27. These other layers, if you reset them, take the cells back to the age of 25 years.
Right. And when you say the section, were you referring to Waddington, Hux, and Lindenmayer systems or sections, or?
No, Johnny, those are whole body. No, those are whole body systems. We're talking to things like the eye, to the retina, particular sections of the human body. Yeah, but those things are the Waddington attractor, the Hox complex, and the Lindenmayer systems. That's for the whole body. Those are systemic systems.
It's in the group.
Good. Yeah, I could use a younger retina. Mine's been kind of beat up over the years. Well, that was very informative. Thank you, Miles. Is that Robert had a question?
Well, actually, I have more of a comment. I think this is very interesting, and one thing I would like to point out that I think it was around 2003, the Methuselah Mouse Prize started with the idea that we could prove life extension if we could get a mouse to reach age 5.00 years. And so far, over 18 years, they've come to 4.98 years, which is within 6 days of getting there, and they failed. I really believe that if what you're saying is a correct hypothesis, that this would be a major factor in terms of extending the human lifespan. We should be able to test this in mice in clinical trials and get the results fairly quickly. And if you're seeing mice turning into 6 and 7 years old, then suddenly you've hit the big breakthrough that everybody's looking for.
And hopefully it will translate to humans.
Well, that is the question, but I'm considering, what he's talking about on the epigenome level, that people think that we're so different, from other species. But when you consider that when they're testing evolution on Earth, every organism on Earth, mostly, at least for the DNA organisms, we're not sure about viruses, but with the DNA organisms, trace back to a single point of origin approximately 4 billion years ago. And the first 3 billion was basically development of the one cell organism. So when you consider that the last billion, only 25% of our genetic expression is in the last a billion years. The reality of it, we're far more similar to other species than we think we are. So I think that if you can get a mouse, we know that the mouse has the mammal lifespan. Humans have a mammal lifespan. Dogs and cats have mammal lifespans. They all have a maximum lifespan that seems to be species delimited. And we know that what the mouse record, 4.98 years, is stood for over 15 years. And we do believe that, if you could get a mouse to, 5.5, 6 years, you could demonstrate the big breakthrough. So far we had the breakthrough in worms and yeast and flies. What about a higher organism? Let's see if we can, one problem, if you have a turtle, turtles can live 200 years. It'll be very long wait to demonstrate life extension in a turtle. But if the mouse record's only 5 years, it won't take, take 6 years to show that, 6 years from now, that's 2027, we should be able to get these results fairly quickly, I think.
Excellent. Well, let's then move along to the next topic. And I'm just going to stress that these topics are loose. But we should probably work through them. I think they're all high value. I'd like to show my screen. The next little topic is gene editing and gene therapy. And so far, I've been following the work of Liz Parrish and her partner company, Integrated Health Systems. And I know some people who have had that therapy. And have shown some biomarker measurements that shifted towards youth. So fantastic. It's just a start. And I see Ellie just joined us. She's an outstanding member of our community. Let's see if she's still. Well, she'll be joining us shortly, but I'm gonna just show my screen. And does anyone have anything really great about gene editing, gene therapy, and particularly knock-ins of youth enhancing genes and characteristics that you'd like to share? Okay, I'll show my screen, and I just, this is among the many therapies I plan to work on. We're always fighting the battle of time. We need more time, but when you look at it, that's what we do when we try to get longer health spans and lifespans. But anyway, I keep lists of genes that would be youth enhancing, that ideally, potentially someday we could knock into our own genomes. And I'm, I'm very first to admit that I'm very lightweight in terms of knowledge of those, as well as many scientific concepts. There's some things that I do pretty good, but I'm not really a great scientist. Plus, I kind of have a lousy memory, which is why I have to keep lists of things. But you can see a file that I keep. Well, a few years ago, I helped Liz and her group build a gene therapy database. That was kind of a fulfilling project. It was worthwhile. George Church has a list of genes, and I'm all in for, well, one of them is for low aging, I think. I think I took the words low out of there, we'll see. Also high learning and memory, less sleep, more fingers. We all need more fingers. So hey, I think this is the page. Come on, page, load. Well, this is it. So anyone who wants this, just let me know and I'll put it in chat or I'll send it out later. It's just a list. So here, positives, extra strong bones. Yep, I could use those, but there's with every positive, there's a negative. You would be less buoyant. So I suppose if you fall in the water, you'd have to have increased muscle capacity gene and you know, a better swimming ability gene or more stamina or something to counteract all that extra weight you're carrying around. But anyway, okay, Gunther's joining us. Hello. Okay, MSTN, large, lean muscles, low atherosclerosis. Okay, pain insensitivity, I don't know. That might be good up to a point. And I don't know, I don't remember if the low aging is on this one or the extra fingers is on this list, but it's just a list. And it's one of many lists that I'm compiling for when the time is right. And really the CRISPR or whatever, you know, technology is more developed for us to actually do this, that they would be potential target genes to go after. Here's another list. Brian Bishop has a very nice list of genes. He's a very altruistic individual. He wants to help future generations, and that's fantastic. Yeah, here he's getting, yeah, the Milano allele P53 overexpression. So his list is very nice. It describes what they are. He keeps them up on a wiki. Let's see. Yeah, something for us to remember. The gene therapy needs to actually get inside the cells. I've suggested that the blood-based diseases would probably be easier candidates for, well, I probably suggested that because I heard someone, surely I heard someone else say it. Yeah, it's all coming back. You know, the blood-based therapies would be, you know, low-hanging fruit candidates, but also inside the eye. And I'm hearing that there are gene therapies to fix degenerated or aged retinas or retina diseases. I seem to recall hearing somewhere or reading that those have been successful. Okay, Tim W.U. of Boston Children's Hospital from Precision Engineering of the Genome and Epigenome Transcriptome. Here, you know, we have these, he made a YouTube video and there's a link here. I don't, you know, you get the idea of what these are about. It's just bits and pieces of different things. No coherent plan or anything, but you know, it starts with a list, I think. And then here's other ones I've heard of. So I'm gonna jump out of this. Just various lectures and other links. Megalis is doing some outstanding work that's high on his interest. Here's discovering new cell senescence genes. So that would be useful. So that's that. Just let me know and I'll email this document to you. Send me an email, I think. So I will now, I know that was kind of choppy, but I will now turn the conversation about gene editing, gene therapy, and knock-ins to youth-enhancing genes over to anyone else who would have something to say about the subject. But just let me preface it. I'm well aware that we are some distance off before actually turning all this into reality that we can use to stay younger. So anyone, take the floor, please. Some of you seem frozen. Is anyone say something?
Did appear to be frozen.
I see Bill Lawrence moving.
Okay, that's
On a once a week schedule.
Well, it's similar to what has been proposed at
I'd like to add something about that. The proposed doses for dasatinib, I think by Brian Delaney, is too high. They were basically taking the weight of the rats and just doing a linear conversion rather than doing a body surface area conversion. And also the dasatinib, even for its approved indication, doesn't vary that much. The dose doesn't vary much by weight. So I find that people who are taking 300, it's just too high for that dasatinib. The dosing is between anywhere from 100 milligrams to 150 milligrams once a week. Another thing I found in looking for some sort of correlations in the database is people who did not do a pulse dose, that took consecutive dosing, meaning on consecutive days, typically more than 2 days, 3 or more days of consecutive dasatinib dosing, they actually did not do very well. They would write in their posts that people say they look older. So, so if you're taking dasatinib chronically, that is you're not pulse dosing it, then it would be very counterproductive. As far as for COVID, if you've got senescent cells in your lungs, and if dasatinib helps reduce that, then you would be better prepared if you do get it. The fever resulting from dasatinib, not everybody gets that. I get it, but it's not the same as like a fever from a virus. I've done about.
Jeff, I agree with the dosage. I think that's really a good thing, 100 to 150. I weigh about 137, 138, and I take 115. But taking it weekly, that scares the hell out of me, man. That stuff can do a lot of harm. I didn't believe when I heard you said that. I mean, maybe it's just my knee-jerk reaction, but I think when we were dealing with that kind of stuff, we're dealing with the devil. And I really like to know more statistical information from Jeff Parker also, because that just seems to be too much. it's one thing with cancer because all the senescent cells it produces. But if you don't have, we ride along with cancer our whole life, especially when we get older. And I just think that's way too much. It's my opinion. That's all.
Well, I've done it twice, about 6 months apart, and my dosing was 125 to 150 dasatinib, and I think roughly 10 times as much quercetin at the same
Quercetin,
time.
yeah, quercetin.
And I weigh about 100 kilos, so 220 plus. I had very mild side effects. I mean, sometimes I'd have chills the first day, but usually only the first time, and then subsequent. We'd do them a week apart for 4 to 6 weeks. I had experienced a nearly complete remission in my arthritis in my knees that lasted 6 to 9 months. And that happened twice. So I feel that it had detectable positive benefits for me. We only did that after we kind of studied other user experiences. It was a non-scientific study. It was because everybody's protocol was different. There's no way to like come up with some master formula. So it was somewhat subjective when we analyzed the data, but we got confident enough to try it ourselves. I think we had less success with Fisetin in terms of trying to get a successful, any detectable results. So
I find what you're saying, Jeff, about your knees very interesting because I do have a certain amount of senescence in there. I know that, and I've done some things. So I might try to increase the frequency, but I'd rather underwhelm things than overwhelm them. I don't know. I think I like to play it safe. It's called "This Is Your Life." So
well,
I appreciate what you're saying. Though I think I will increase the frequency.
The Grim Reaper is after us, though. We don't have, at my age, I don't have the luxury of waiting for more studies. I sort of feel like it may be 20 years before we have proof of what we're trying. So, and if I don't, so I'm willing to take some chances.
I'm 78, so it isn't. I'm not exactly a youngster, Jeff.
It's a calculated risk, and I did have another guy tell me the pain in his knee was reduced after dasatinib plus Q.
Mm-hmm.
So
and you're saying, Jeff,
worth.
I'm sorry.
Go ahead.
And Jeff, you're saying you tell me your frequency again. I just want to hear it again because I am.
Once a week it was a pulse dosing once a week, and I did I think it was 4 or 5 weeks the first time, and maybe 6 weeks the second time. At the first time I did was 125 of dasatinib, and the second time I did 150. I titrated it up to 150, but and again, I think the first time of the cycle there was some maybe chills or something the first day. After that, there were really no side effects.
I never had any side effects from it, but you see, I'm cautious about it.
Yeah.
But you do quercetin. Why don't you do EMIQ? It's got a better bioavailability.
I can answer that. A study used dasatinib, a study in Texas, dasatinib plus quercetin, and they used quercetin phytosome, which I think is made by Thorne. So sure, you're going to find other forms of quercetin that are more bioavailable, but we chose the quercetin phytosome simply because that was the one that was studied against dasatinib in a human trial.
That's good, Jameson. Thank you.
Question: what is the advantage of the pulse dosing as opposed to the once a year? I did it on a once a year basis. I did it once, had fabulous results with the knee, as well as energy wise. I'd say it rolled back the clock for me about 10 years. But I took the Brian Delaney dose, so I had a major side effect the next day, but well worth it. But the pulse dosing concerns me. So what is your rationale to do it that way?
Well, you essentially did a pulse dose, just one dose.
Yeah.
Well, I recommend doing it in the course, and this is based on my analysis of a whole bunch of users on Longevity. I had my virtual worker compile every post, and what they wrote was their dosing and their protocol. And I was trying to determine what is the ideal course length. Something like 8 to 12 weeks. So that would be 8 to 12 doses. Would be just one course. And then you may not repeat it again for another year or 6 months, or never do it again. But doing that, you take the statin plus the quercetin in the morning, and that's your whole dose for the week. But I'm not talking about doing it continuously. That is doing it beyond 12 weeks. I've only done, in the last, 2 years, a total of something like, 13 to 17 doses. That's it. I mean, and so it was in about 2 courses. So on side effects, I tried making some adjustments to the quercetin. I was suspecting that the side effects may be related to quercetin. In the last 2 doses that I tried recently, the side effects were worse than the first time. I actually got nausea. But what I determined is that if you're doing the statin plus quercetin on while you're doing intermittent fasting, it is a lot more potent. And the nausea will come in, and from what I've seen, about 10 to 12 hours later. But that did not happen the first 8 doses that I did last year, but doing a more aggressive intermittent fasting. So maybe if you were gonna, what I did the last time is I decided to just take the dose earlier, and so that my meal time would overlap the time that I start to feel nauseous, and it seemed to work that time. So as far as the nausea side effect, that would depend on whether or not you're fasting or not.
Yeah, I was fasting though inadvertently, so that could have contributed to the side effects. But by the time I got to the dose, there were many things. It was not self-administered; it was administered by a doctor. So by the time we got together, it was late in the afternoon. So essentially, I was doing fasting. Now, are you aware of anyone working on nilotinib, which crosses the blood-brain barrier, using that instead of the statin?
I'm having trouble hearing.
Nilotinib, it's another leukemia drug.
I can't. Your audio is too low.
Oh,
Here's having trouble too.
I'm trying to.
There you go.
Yeah, I can hear you better.
It crosses the blood-brain barrier. And so I don't know if anyone has tried to do Senolytics with that. I'm really interested in that one.
Yeah, and I believe the word sounded like melatonin.
NIL, nilotinib.
MIL.
NIL, yeah, it's a leukemia drug. They're doing research at Georgetown.
Could you put the spelling on chat so we can see it? I'm still not getting the correct name.
Okay, I'll see if I get on the chat. My chat box is not coming up, so I'll add it when I can. Oh, here we go.
So that's related to dasatinib? Is that the same drug class?
It's similar, but it crosses the blood-brain barrier. It's used for leukemia. but they're experimenting at Georgetown with this drug for Alzheimer's and dementia and have had good results. And so, but it's the same concept, Senolytics, except that it crosses the blood-brain barrier. And from what I've read, there are fewer side effects with this than with the dasatinib, which has been administered to the leukemia patients. So that would be, from my perspective, what I would want to do next if I could locate a supply of it.
Yeah, well, I'm not familiar with that drug, and of course, you know, we're getting a hold of some of these drugs is challenging. I think the people that are doing dasatinib, most of them are getting from a pharmacy in India that is supplying pharmaceutical product. But a lot of these ones you can't find them. At least, you know, maybe you can get them prescribed, but I don't know too many doctors that are prescribing Senolytics. So
yeah, no, the dasatinib I got from IAS in England, but he doesn't offer. I asked him about the nilotinib. He doesn't offer that one, but he does offer the dasatinib at a good price.
mm-hmm. Okay. Not hearing you, Johnny. You're muted.
Okay, yeah, Jameson, Jeff, could you elaborate a little more on the immune suppressing effects of rapamycin, particularly in a time of COVID?
I can talk about my experience with it. I took one dose of the rapamycin. I think it was early last year, or maybe no, the year before. 5 milligrams, which is, you know, the pulse dose. And I remember subjectively I had some cold, clammy hands, but then I had like an infection in my left leg that became a problem, and I was getting scared that my leg would. So, you know, I went in the bathtub, filled it up with like a disinfectant to see if I could stop it. But I suspected that for 2 days, the rapamycin must have just turned off my immune system. So I was really scared by that. So I decided to not do it again. And it figure if you're vulnerable for a couple of days, you don't even want that in this pandemic. And that's one of the reasons why I transitioned to intermittent fasting. Is, you know, the purpose of rapamycin is to induce autophagy, but you could do that every single day with intermittent fasting. So it seems to me you're going to get, your benefits a lot more safely through intermittent fasting.
I have been doing ripamycin for a little over 40 years on a weekly basis. Every 5th week, I stop it. I take 6 milligrams. As I said, my weight was a high 130s. I do it on my fasting day. Believe it or not, fasting. Let me explain what I do. Once a week, in a 38-hour period, I eat a total of 500 calories. And the other, actually 6 days, I do autophagy for 14 or more hours continuously. The only time I ever had a reaction to rapamycin was because I was stupid enough, the first time I ever did it just a tiny bit, I mean a tiny bit, got on my hand and ooh, and I just licked it off. Don't ever do that with your tongue because you will have one hell of an effect. That stuff is powerful, but I have never had any other effect. And you know what we're doing now is we're talking about human variation. That's something that makes it so difficult to really define what we should and shouldn't do. I read a study once about 4 or 5, maybe about 7 or 8 years ago, I think it was. But they said in, excuse me, in the previous decade, on phase 4 of all approved drugs, 33% had effects that the trials never uncovered. So we have so much variability. Probably the epigenome is a big factor in that. So we're in the Wild West, whether we like it or not. We just have to do the best percentage we can and have these kinds of discussions so we can learn from other people, which I'm grateful to having.
Well, we follow Dr. Alan Green, and he's the big proponent of rapamycin, but he's also more recently beginning to prescribe Senolytics for his patients. He's pretty aggressive on that, but he's a big proponent of the pulse dosing, and I think what we believe is that with the pulse dosing, your immune system is suppressed for maybe 36 hours, and then it fairly rapidly recovers. So if you're worried about COVID, we want to, and you're going to try rapamycin, you will maybe want to be isolated for, 36 for a couple of days before and a couple of days after you take rapamycin. Avoid crowds or places where you could get exposed. But I have a friend, for example, who's taking it daily for organ rejection, and he's under the almost daily care of doctors overseeing that, and they're he's received his COVID vaccines, and they weren't concerned about that. And if anything, they were concerned that the rapamycin might make the COVID vaccine ineffective. That was the main concern. So, and I've got another friend who's been taking it on a pulse dosing for inclusional body mitosis, and it's basically kind of replicating a clinical trial. He's doing it as self-experimenting. The clinical trial was a failure, but the clinical trial used daily dosing, which we think doesn't really help with autophagy. So anyway, that's our input on rapamycin.
I have something to add. I also had our virtual worker compile a bunch of data points on rapamycin, and the side effect that I experienced, nobody reported that. So from what I could tell, it's actually pretty safe. Most people don't really experience any adverse problem with taking the 5 milligram rapamycin once a week. So in my case, I was trying to figure out if anybody had encountered the same problem and had found a way to mitigate it, but I haven't found any mention of anybody experiencing that problem. So,
Jameson, I had an experience that's not that problem exactly, but similar. I'll relay. But first, Stan, did you say a little piece of it came off, and where did your tongue burn off, or did your skin?
It developed like a boiler or something on it for about a week, then it went away.
I'm pretty sure I know definitely with dasatinib, it says do not cut, do not crush. And I seem to recall hearing for rapamycin the same thing. You could look it up easy enough. Don't quote me on that. I'm not sure. But yeah. Here's a recent experience that I think all of you may find useful. And it kind of reminded me of a stupid mistake I was making like over 20 years ago when I was overly aggressive and naive, just trying to do too much, just trying too hard. I'll just, say my normal method is to do a lot of different types of things, to hit different body systems, but nothing that would be considered overly aggressive, and trying not to do damage. I like the Kaufman protocol, and I follow a lot of her recommendations for the different types of nutritional supplements, and applying them to the different, I think she calls them hallmarks. But anyway, here's what I did. I was very greatly cutting back on food intake, where I was just consciously aware not to eat a lot and only eat when I get like really pretty hungry, and then barely enough so that when I'm satisfied. Also, I had bought the Prolon foods, not intending right now anyway to do their complete program, but to, to kind of make up my own and to use some of their foods along with, just working my own system. It has to be personalized and work for you, in my estimation. I don't do well following the program. So, and I'll find their soups are really filling. And also another sidebar, there is you can look it up, HMR, it's a diet supplement. They have these shake drinks and they have meal things too, but the shakes seem to really kill the appetite for a number of hours and fill you up. I don't know what it is about them. You mix them with ice and water. But okay, so for about 4 or 5 days, I was reducing caloric intake, and I finally had my scales shipped from California, and each morning, roughly watching, a decline by about 1.5 pounds, something like that. So that's maybe a little less, but to be expected. Okay, but then one day, 3 days into this, I took a rapamycin, and later, this is in some ways similar to what Jameson reports. My extremities, my legs in particularly, and partly the arms, but mostly the legs just felt weak, and I felt a little off, just a little odd, maybe a little ill. So, okay, I thought, well, skip this for a day at least. Next day, I felt fine. So the next day, I did my high intensity interval training, and I did rapamycin. Oh, I didn't tell you, it's just 1/2 of 1 milligram, real low dose. But I'm satisfied that first time that it caused that effect. Okay, now I'm getting to the interesting part. So, again, just 1/2 milligram of rapamycin. And I personally, through experience, I believe I'm susceptible to drugs more than most people. But anyway, that high intensity interval training, plus I started a fast at 1 p.m. Now at about 10:30, just before bed, I took 2 life extension senolytic activators. That's the recommended dose, plus 500 milligrams of dose of quercetin, plus I forget the number, but a comparable amount of quercetin. And by then already I was getting hungry, really hungry. And then in the middle of the night, like about 3:30, couldn't sleep. And I was so hungry, and it was a strange, empty kind of hungry, and, kind of a pressure kind of hunger, different from what I was usually experiencing. I was recognizing something was wrong. I better eat something. So I had about 100 calories and did my relaxation exercises, managed to go back to sleep. So, okay, at about the usual time, about 6:30, I took a half dose of Longevity Edge beta hydroxybutyrate, which is associated with ketones or ketosis or something. Then I figured, well, what the hell? I was really pretty hungry, so I'd keep, I don't know if it was good or bad or whether it was going to keep the ketosis going, but I went out for a bacon and egg breakfast. I didn't overdo it, had a little toast with it. Plus that day, I ate, later in the day, I had a hamburger, and I ate fairly, without overdoing it, but fairly heartily. Now that day, I felt really weak, and I knew something was going on, something was wrong. Okay, now that morning on the scale, I was 144.4. That is my ideal low target weight. So I had dropped about 1 pound, or maybe 1/8 of a pound from the day before. Okay, so that day I just didn't exercise. I was taking it easy. I had a feeling something wasn't right, particularly in the legs and arms, but just felt generally weak. So I was able to work. I believe my mind was quite sharp, and I was able to do great work, such as it is, but just feeling weak. So that night, slept pretty well. The next morning jumped on the scale, it was 143.4. So I lost, while eating normally, no exercise, I dropped another pound. And I'm, this is N equals 1, very incomplete information, but it kind of seems like something was going on to reset something and set it downward. So that next day, I also thought, well, I'm going to get some blood work done. So I went to Life Extension. I keep a CBC metabolic panel plus CRP test order on hand, and not Life Extension, but LabCorp. I got it from Life Extension. Unfortunately, here there's in one of the pharmacies, there's a LabCorp satellite that's open on Saturday. So I went down and got it done. Fortunately, some values were a little different from what they were about a week before. And, some numbers were a little better, some numbers were a little worse. I popped it in to something we want to talk about later, the Levine Kramer Phenotypic Age calculation spreadsheet. And the phenotypic age was in the same range. And also none of the markers were strange or excessively out of range, indicating, liver or kidney damage or something like that. So anyway, that day, that was a Saturday, I still felt kind of weak, less weak than the Friday, the day before. And then Sunday, pretty much back to normal. I still, imagination is a strange thing. I think Sunday I still felt a little odd. Saturday, I definitely felt odd, but I believed I was able to do my work, effectively, if not more effectively than ever. So I wasn't going to go through that lengthy account, but I don't know. I'm just hoping it's useful, and I'm going to carefully consider rapamycin going forward. Oh, another person I talked to advised that he no longer takes rapamycin. He does a lot of fasting and he has outstanding biomarker measures. I asked him why he stopped taking the rapamycin. He said he was losing too much weight. And he's more or less a, average weight for his height. So thanks for listening to all that. Hope it's useful. Anyone?
Can we go back to the previous topic of other interventions? I didn't find the unmute button quickly enough when you passed through that topic. But I posted a couple of times about the recent Baylor study of using glycine and N-acetylcysteine as a treatment for sarcopenia. I found that study quite remarkable. It's a very small study, but they kind of made up for it with lots of testing, and the results were pretty astounding. And it's something that is an intervention that seems quite benign. I'm actually planning to try it, although I'm still in the research phase of trying to find out what the downsides are and what the risks are. Did others read that study? Basically, you're taking large doses of the amino acid glycine together with N-acetylcysteine, and N-acetylcysteine is a prodrug for cysteine. It basically delivers cysteine, another amino acid. And the purpose of the intervention is to increase cellular levels of glutathione. The glutathione is a tripeptide that consists of glycine, cysteine, and glutamine. And apparently supplementing the glutamine is not necessary. It may actually be counterproductive. But they achieved increases in glutathione level that are far greater than I've ever seen with, say, like taking liposomal glutathione or anything like that. They were like doubling it. And there are also these the studies was producing faster stamina, 6-minute walk test improvements, grip strength improvements. And they were also comparing it to a baseline of like 8 other participants that were in their 30s that were sort of matched by size and weight and sex and so forth. And in some cases, the 70 to 80-year-old cohort started getting results that rivaled the 30-year-olds. And this is like the holy grail, is like age reversal, not just stopping. And so I was quite intrigued by the study, and it's using large doses of 2 fairly benign substances.
You have information on that, a link that I could take a look at? I'm interested in that, Jeff.
If you scroll, in fact, I posted something that came up. I think it got posted on GRG this morning. My follow-up on it, and I included a PDF of the actual study on that. So it's in today's GRG, and it is a copy of the study.
I've got it. Thank you. I didn't open it yet. Thank you.
Yeah. So, there wasn't too much discussion of it when it first came up, and I think there was a period of time where Johnny, your email went down, so there was kind of it may have sort of been lost in the shuffle, and if people don't follow topics very long before people are moving on to other topics. So I was hoping there would be more discussion of it, because I thought it was one of the more interesting studies I've seen in a number of years in terms of things that you can do at home, kind of like self-help things. Johnny, you're muted.
Okay, Jeff, did you say that that's something you're going to do?
Yes, I've acquired a supply of the 2 supplements. They sell it in powder form, neutral cost, and bulk supplements sell kilo quantities of the 2 supplements. The one concern that I've been researching is that NAC, N-acetylcysteine, is used actually is FDA approved for one use, and that is for liver poisoning, for Tylenol and mushroom poisoning. It's used in hospitals in very large doses, but these are very large doses too. And it doses over 7 grams a day. There is a side effect profile. Some people get GI side effects, upset, or skin rashes, and I've been trying to find the actual toxicity study that reported those to see what the dosing really was, because the hospital setting, the dosing can be up to 50 grams a day of NAC for liver poisoning. So it's I don't know whether they said that these side effects were seen at over 7. At least that's the kind of the third-party reports, but I haven't seen the actual study.
How will you measure the results, Jeff?
Well, I'm about to get I've actually the request of my one of my doctors has taken me off is suggested that I go off of everything for 5 or 6 weeks, and so that he can do a baseline of all my testing without any supplementation. And I'm just about finishing that now, so I'm going to get a baseline of a fairly comprehensive panel of blood tests. Having been off everything for 5 weeks. And then I'm going to start this thing. So I'll have a baseline for comparison of nothing. But I unfortunately, I don't think he specified glutathione. It's not a test that's normally done. So I should maybe get one of those too as a baseline.
Jeff, are you aware of the fact concerning NAC that about a half a year to a year ago, Big Pharma tried to get that as a medicine and not a supplement, so it will be taken off the market as a supplement? And the reason is exactly what you said. It had one medical purpose. I don't know the results of that, but I know they were trying to take it off the market as a supplement. You have an
Yeah,
update?
well, I've got a cynical attitude about big pharma. You know, when something works and is beneficial, they don't like it unless they control it. But NAC is N-acetylcysteine is not found in nature, and normally would be a prohibited substance under FDA rules. However, it was in wide use before and before the whatever that supplement act was. So it's considered grandfathered. But they've been
Good.
trying. They've made several attempts to try to like get it banned, but there's usually an outcry because there are a lot of people that use the stuff and are pleased with it. So
That's a good update. I really appreciate it. I stockpiled it when I heard about it, and I still got a lot.
yes.
Well, how do you think it would compare with weightlifting and, for the cardio component, some sort of cardio exercise?
Well, I think the Baylor results were just better than all of those. I mean, what I find is that I think a lot of us at our age, we're doing a lot of those things anyway, but it's still somewhat of a losing battle. I mean, we're going to succumb to sarcopenia, between the age of 70 and 90. And if you can prevent it from starting or head it off early, I think it'd be much better off than sort of waiting until you're frail and lost all your muscle mass and then trying to reverse it.
Yeah.
So that's my why I'm so interested, because I'm just I'm 72 and I'm I'm exercising more than I ever have in my life, but I'm still feeling that in a way I feel like I'm just sort of like maintaining, I'm not gaining.
Jeff, what dosage were you going to take then of the NAC and the glycine?
Well, there's a formula in the study. You have to translate it from molar mass to grams, but basically, I'm almost exactly 100 kilograms, and so my dose would be 10 grams of glycine a day and 13 grams of NAC per day. That's for a 100 kilogram person, and the study indicated that it was purely by weight. I don't know whether this is one of the ones where it's more where it's nonlinear, but the study administered it by weight.
And Jeff, is this something you would be doing continually or doing it intermittently?
Well, the study was for 6 months, and the interesting thing is that the results were somewhat continual. I mean, the second 3 months had a substantial improvement over the first 3 months. So one wonders whether the improvements would continue if they made the study a year or 18 months, whether the improvements would continue. Because they stopped it after 6 months, and they also found that they'd also tested them another, was it 9 months later? I can't really remember, but 9 months later, they found that a lot of the results had reversed themselves when they stopped the study. So.
Did you say you'll be taking 12 grams of NAC a day?
13.
Okay, thanks.
And I think that I'm guessing that the study did not say how many times a day or when, but they had them all the study had them compounded into capsules. So you're talking about probably 24 capsules or something. I'm sure they split the dose, probably morning and evening at least. So that's the other thing, is that splitting the dose is probably going to be easier on your stomach. That's the main thing, is whether it's going to cause GI or rashes or things like that at that level. Now, there is also another thing is that there's some people who say that direct supplementation with cysteine is better than NAC. And that's really the goal, is NAC converts to cysteine and the cysteine converts to glutathione. So I'm also thinking about splitting taking some of the cysteine in the form of L-cysteine rather than NAC. It's roughly the same molecular weight, so it's about the same dosing.
You know, I was very interested when I saw your headline, because I've been taking NAC and glycine just independently, but not at those dosages.
I've been taking NAC for probably 10 years. I mean, I take those extended release ones from Garo, the sustained release ones. I've been taking those every day for 10 years. I think I think it's a great supplement, but not at those doses, you know.
Right, exactly. I was taking 600 a day.
Yeah, right.
So you did see an increase in terms of the side effects when you upped it to.
I haven't started yet. I'm still in the research phase, but as soon as I get my new baseline testing, I'm probably going to start this thing. So
Yeah, well, looking forward to reading your report once you get started. Thank you for being the guinea pig on this one.
Well, I hope I've got positive things to report.
Hopefully so. Yeah.
Would you, if you would, please email me the test you're going to do, and if you're open to any thoughts or ideas.
Yeah, I might want to look at adding some things to the testing baseline, because I think what is my diabetes doctor is probably a fairly routine panel that he's doing. So
well, are we on to the next topic?
I don't have anything more on this. So
okay, well, infusing youth enhancing factors like young or cord plasma, etc., into the blood, says from the blood, but into the blood, and removing pro-aging factors from blood. Just on the first one, the only thing I've had personal experience with, both myself and others, is cord plasma, where DNA methylation and other methods shifted. In me, I took a low dose. I'm a low dose guy, and it shifted DNA methylation and some other measures somewhat towards youth. And that was after 10 days. It would be great to, to measure it every day or more frequently, but that's what it was. But my associate, who took 13 times as much as I took, over about a week period, he experienced a shift in DNA methylation of over 4 years reduced. So then another associate who regularly has the infusions subjectively reports a better tennis game. And I've learned to listen to these tennis players, and they're pretty well in touch with their bodies, but you can take that for whatever you feel it's worth. Now, recently, you may have read about the work of the Convoys and Dobry Kiprov, and they remove with each treatment, it's about 2.5 liters of plasma, and replace it with saline plus albumin from younger patients. And at the end, they top it off with an IV or IG or IgG IV push. I think I got that right. And one individual in our circle of associates went up to San Francisco to have that treatment. He's the tennis player. He did not repeat the treatment. He did not report any positive effects. 2 other individuals had all 6 treatments, and one of them has had a reduction in DNA methylation age of several years, plus no negative effects. The other one, he initially reported positive subjective experience, both in terms of his reporting of how well he felt, plus his tennis game improved. And he told me that another person or persons commented that his tennis game was better. And let's face it, on the tennis court, I tried it a few times, but it's not only hard work, but there are a lot of different moves. You have to, go in every which direction. You have to be quick. It's a measure of stamina. So you can take it or leave it, whether you believe a subjective report of someone doing better on the tennis court is valid, or whether it's placebo, your call. But anyway, we do have at least some objective measures to the positive effects. And for you East Coasters in Boca Raton, Richard Gaines is an innovative physician here. He is allied with the Conboys and Kiprov and a part of the study to administer the, or I should say, remove the plasma and replace it with saline and albumin and the IgG. So that's everything I know about that. Your turn.
Yes, Johnny.
Hello.
Yes, no, I actually went to ask a few doctors about some sort of trial for this. So I asked two doctors, a professor, and then I also went to a company that actually does clinical trials here in South Africa. They are doing clinical trials for tuberculosis and for HIV. And they all said this is interesting. It's a fairly simple procedure. But of course, the question was, what sort of funding mechanisms would there be? So I think we can talk about that later when we speak about funding. But I did go and check up on this one because I think it's something we can pursue. Thanks.
Oh, okay. Oh, yeah.
Johnny?
FYI, the treatments, it's self-funded. They did 6 of them at $6,000 each, plus travel costs.
Hi, Johnny. Akshay.
Hello, Akshay. Hello.
Yeah. I don't know if anyone here remembered someone posting on GRG about a Chinese study recently on mice where they extended the lifespan by 26% by just giving them recombinant albumin. They did not remove any plasma in old mice. They just gave them recombinant albumin and they had this effect. So Kiprov has always been saying that the benefit lies in the albumin, and it kind of validates his contention, although it's only in mice. Again, it's some intervention that is very easy and safe and can be administered by any doctor.
Outstanding. Thank you.
I just want to throw in a piece of trivia. I ran into someone who knew Keith Richards of the Rolling Stones. Back in the 70s, he was getting blood transfusions on a regular basis. And I always wondered how he'd managed to stay alive given the hard living that he'd done. I don't know who he was seeing, but apparently it seems to have worked for him. He's still alive.
Yeah.
He certainly doesn't look very young, though.
No.
Yeah, but he's alive as opposed to dead.
Yeah, I think he lived rather hard in his youth. So
Yeah. Well, let's move along to what is the next topic? Ooh, an online lab report data extractor and Phenotypic Age calculator. I'm going to share my screen for this. With this, in a past life, before I just quit the workaday world with the intention of just solving aging, I was in, several past lives, but the most recent one, data analytics, databases, software development, and computer programming. And I have used as one of many tools the spreadsheet that is based upon the work of Morgan Levine and Steve Horvath and some others. But John Kramer is a very innovative member of our community, took that work and put it into a spreadsheet so that you could enter your lab report data and calculate a phenotypic age and some other measures. So I'm going to share with you something that I created drawing on my software skills that is going to be available for you to use. Bear with me a moment. I had this set up, but I think I wound up shutting it down. Too many screens open. Let's see, first I will show you the spreadsheet. It's opening up the software development environment, sorry. Stop it. Yeah, I had all this set up, but okay, first let's take a look at a lab report. Here's one. You've seen lab reports before, but this is what we're working with. Okay, so wonderful. That's a lab report. Here is a version of the spreadsheet. I took the good work that John had done, which was really the core of this and the heavy lifting, and added some references and used some things to make it a little easier. Have any of you here not seen this? Probably at least a few. I'll just take you through it. But you know, you put in your date of birth, your test date, it calculates the age for you. You put in, hey, here's our old friend albumin. Mental note that what Morgan and the team did is they analyzed lab reports to see which measures could be distilled into a phenotypic age. And that is basically they compared everything with DNA methylation as a baseline. And albumin is in there, so surprise, along with some other things. C-reactive protein, of course. This is a bit of a surprise. Mean cell volume and red cell distribution width. And the reason, I talked this over with John Kramer a couple days ago, the reason there are weights assigned to these, and that's in this row 17. And for these two, they're fairly high. And that is because it's believed, suspected that in young people, well, the longer these cells hang around, the bigger they get. So we want smaller sized white blood cells and red cells. That's it in a nutshell. I've terribly mischaracterized that. But as people age, they tend not to clear and replenish their cells. And that could be a problem, particularly, well, with a lot of things. Here's our friend glucose. We want lower. Here, albumin, one of the things I did, I put in, and this is a rough gauge because the weights is very important, but I just put in that higher albumin is better than lower in general. Is it possible to have albumin toxicity? I suppose that you would reach a point where it would be very bad, or where, you know, it's not as simple necessarily, like there might be, ineffective, aged albumin, toxic albumin, I don't know. I just don't know. So many things, but lower creatinine is better, low glucose, low C-reactive protein, and etc. So all of these numbers from the lab report, we've had to enter manually with the typical entry errors that might be inherent to get the phenotypic age. And notice this subject at this point in time, his cron age 70.46, phenotypic age according to this 60.46, so 10 years younger according to this one measure. Now, note that the chronological age enters into this, so you could take this out of the picture, and you can tweak the chronological age and see what changes. But the point is that these measures of in this age result in, for most age groups, a phenotypic age that's somewhat younger than the chronological age. So getting these reports and entering them, and then, okay, you have a spreadsheet, what? To keep track, perhaps cutting and pasting things or transcribing things into databases, and then, you know, that's a problem. What's the next thing? So with the help of the associate who actually trained me 25 years ago when I first entered the software game, I took a look at this and I just figured it can't be that difficult to extract the values from these PDF reports. You know, I looked into it a little deeper and was told that oh, this isn't good, hang on. Was told that what you see in the fancy, pretty PDFs is simply things to make the text look prettier. And that is in fact the case. So here, it'll load on the right page now. So what you do is you first need to choose a file, and it has to be a LabCore. I have not yet tried this with Quest or any others. Probably wouldn't work, but it might. But I eventually plan to build out different versions of this. But my personal standard and that of those in my community are LabCore. So first you choose, and this is online right now. I'll give you the link for to use it, although I'm using it in design mode just to keep it simpler. What happens if you don't actually choose a file? Well, you get an error message, okay? Choose a file, okay. Go back to step one before you do step two. So let's grab this, this report we were just looking at. We're just looking at the comparable spreadsheet. So it's taken it. So now notice these, half of this is empty down here. It's going to extract and process the PDF. It's going to get the data out of the right places out of the PDF and put it in the boxes. So yes, that is in fact my name. That is my birth date. That was the test date. And these are, I've looked at this 1,000 times. I will certify the right numbers, but you know, you can double check if you want. If I did in fact get the right lab report. Yeah, 71. Let's see, glucose 95. Yeah, so now we're going to calculate the phenotypic age now that we have these. Some lab reports, I mean, I always get the CRP along with my metabolic panel CBC, but you can enter it yourself if it did not find it. So here we're going to run it, and these are the values. The numbers I'm most interested in are phenotypic age and the others, but mostly that. So 60.90, 60.39. Well, mine takes it out to whatever number of digits that it is past the decimal point. John's parses in some of the calculations to 4 digits. So mea culpa for a little bit of a difference in what may be rounding area error. But I will now put the link to the, so many windows open here, to the temporary application in the chat window for you, and you are free to try it on your own. And I did run all this by Steve Horvath and his crew yesterday. They verified the calculations are correct. And I am looking forward to creating the next generation of this stuff, which should be quite interesting. Stop the screen share, open chat. And there it is, so you can use it. Questions, thoughts, ideas? Ideas on how you would like to see this further built out so that you can utilize it in your own research. And I am working on that. No thoughts? Okay.
Johnny, I want to thank you. That was really interesting. I appreciate it.
Thank you.
Actually, I have something to add. Have you got any data from the Baltimore longevity study? It's the longest running longitudinal study on aging. And they should be able to give you the data and for you to like have thousands and thousands of data points to try to build this up.
Oh, you mean to use the system that you just, well, that would be interesting. A very cool project among many, many projects. Where my personal heart is facilitating the development of newer therapies to get us many more years. But it would be useful to go through tons of data and see what everyone's doing, get, using tools like this that distill things down to a phenotypic age and see changes in people. I'm envisioning the SQL state, the SQL database queries now, to look for both what's interesting to me, changes and sharp reductions in phenotypic age, in addition to increases in phenotypic age. And then for that set that have had sharp reductions over whatever period of time, see what they're doing, what therapy they're taking, what exercise regimen they're on, what's going on. So yeah, good idea, Ron. Oops, you're muted.
Sorry. First name is Roy.
Roy, sorry.
Yeah, I'll change my name as soon as we get off for the next Zoom meeting.
Oh, that's okay. Yeah, Ron and Roy. Now, did we meet when your dad was in Southern California a few years ago, or was that your brother?
No, so my dad got remarried, and so I'm following his footsteps in gerontology, but he also has another son from another marriage, Ronnie
Yeah.
Cutler.
Yeah.
And yeah, he's now with Young Vig and Near doing his postdoc work, and he's also into gerontology.
Oh, really? With
So,
near
yeah.
Barzilai? Oh, good.
Yeah.
Cool.
Yep. Yeah, over at Einstein.
Yeah.
So yeah, the Cutlers are still very much into gerontology.
Yeah.
Johnny, whenever it's possible, it would be interesting to hear Roy Cutlero's research. I mean, we have just been introduced to him in GRG, and it would be interesting to know what he is doing.
Yeah, well, sure. What are you doing?
Okay, so I'm actually trying to go after the DNA clock. So I've been looking at what regulates the development clock actually from the beginning, and looking at differences between mainly like chimps and humans, and why the developmental clock seems to be so much slower in humans. And so my hypothesis has been that whatever that mechanism is just all the developmental milestones that humans go through, chimps just go through it twice as fast. And I think that then what happens is the DNA, mainly mRNA, and then the proteins in each organ kind of reach peak function. Like hearing, for instance, peaks out at age 6. Then you have puberty as a good developmental milestone. But then myelination, there's when you stop growing. I mean, there's so many of them, and that seems to have the highest correlation with developmental timing, but also with aging. And so each of these, so what I've developed is a protein profile. Well, it's an mRNA protein profile of when each organ hits kind of the peak function that it was targeted for, and then how it then starts to drift away from that. And so that, and actually, so if you average them all together, it actually peaks out at about age 16. And then I know 25 and 27 has been mentioned here, but like for your hearing, particularly high pitch, really peaks out at age 6 and starts to go down. Synapses, your synapses in your brain peak out about age 10. Cortical thickness at age 10. So there's a lot of different peaks that all the mammalian species go through. But the rate to get to those peaks and then the rate that they decline is very much the same, and it's proportional to the lifespan. So I've been looking at development timing and how it relates to lifespan, and then figuring out what the clock is to really go after that.
Are you working with Steve Horvath, Bobby Brook, folks at the Clock Foundation? Are they providing tests for you?
I've been following their work. Unfortunately, the NIA isn't that interested in it. So I've been kind of a lone person. I've been really just following everybody's work in that. Steve Horvath has developed a great methylation clock, but there's also mRNA clocks, protein clocks. They all kind of are looking at the same thing, and they all pretty much are saying the same thing, that each species has its own clock of different genes turning on and off, and it's really that the rate of those turning on and off that is most interesting to me. Particularly, so lately I've been mainly interested in these metamorphosis genes, and there was a recent paper a couple of weeks ago in Cell where they looked at this one protein. It was ZEB2, that they think really explains the difference in terms of why humans, have so many more neurons, particularly in our frontal cortex, than chimps. They look at chimps and gorillas, and it has to do with the early developmental timing of the stem cells in terms of the neurons. And so it's just actually a difference of 5 days that makes the difference of the number of neurons that humans have in the brain. And I am not that interested in the ZEB2 per se, but the developmental timing mechanism of that protein.
Are you doing anything with, well, you mentioned proteome clocks. Are you doing anything with Somalogic as a test provider?
Not yet. I haven't really published that much on this. I've been kind of just most of my publications have been just kind of dancing around this project, just because I've been getting some pushback, at our institute, and so I've been just trying to drum up support for this, and because I think long term it's kind of at the root.
Right.
They're more interested in doing what you can do now, which is important.
All right, buddy. Okay.
Well, okay. Any more?
So I think. Oh well. That's basically been it. Is that I'm going after the developmental timing mechanism.
Yeah. Someone said okay. It wasn't me.
Oh, that's all right. And the idea is that and that's been greatly slowed down in humans. We are one of the slowest to develop. And if you look at other species like, the Greenland shark, which is one of the longest living, 300 plus years, they hit puberty, at about between age 50 to 100. So that developmental timing, correlates very strongly with, my hypothesis. But I'm not sure if you could actually do anything about it, besides, basically genetic engineering, of designer babies. My next project is actually, doing a mouse model of this. So that's what I've been working on.
Well, you mentioned proteome clocks. I'd like to take just a quick minute and show you what I've been working on. Somalogic offers an array that returns like 4,500 different protein values. And well, Benoit Lahallier and Tony Weiss-Correa wrote a paper recently that identified 490 of them that are, they created a protein clock and based upon 490 of these proteins. So I saw the value in this and set out to recreate it. And, again, like the other thing you saw, offer it to researchers working on really innovative therapies to help them along. So the file is kind of, actually, this is the raw data file from some Illumina, I guess, machine. And it's kind of cryptic. And it just, you have these blanks, then some stuff way over here, and then some other stuff that starts to look like data. There are things that look like headings. There are words over here that look like proteins. It's quite quite interesting to make sense of this, but fortunately in my past life in software, I did a lot of this data extraction and just making sense of things, and wound up writing some processes, creating some processes to extract
Okay, who's carrying a drawer?
Okay, somebody's there. You know, to extract this so it's reproducible. This first started on an incomprehensive text file, which, you know, didn't divide it up into pretty cells like this. But anyway, I'll close this and kind of cut to the bottom line here. What I did is I extracted the data. I worked with Lahalier. He was generous with time and sent me some information from his paper along with some coefficients and the method to apply to each of the 490 proteins to multiply each by the coefficient or by the weight and then sum them. So I did that. And this was, you know, I intend later to automate this, but it was labor intensive. But I ran this process for 64 different individuals, males of different ages. And I just wanted to see what was going on. I don't even know where the data came from. I just wanted to see if there's any relationship with, and you can't see my screen, can you? Let's do something about that. Yeah, I was talking about a data file that you couldn't see. So now you're going to see it. It looked like this. It was kind of incomprehensible. I saw the word checksum. That reminded me of checking things. Then you come to a big open space, but wait, you go out here and there's something that's looking like data. Hey, the word target, these look like they might be genes. And then down here, there is, you know, sample this, sample that, age, sex. Okay, that might be interesting. Here, there's numbers that look, okay, sample ID. Now we're getting somewhere. So anyway, I eventually figured this out and extracted data, brought it into a database, joined it and correlated it with Lahalier's coefficients that I was talking about. And here's a link to the paper. I will put a link to the paper in the chat. That's for you to enjoy. Hang on, where's the chat box? Well, I'll put it in later. But anyway, after laboriously running, you know, 64 of these before, you know, before automating, we see something that roughly looks like a curve, looks like a relationship. Now notice these two 18 and 20-year-olds down here, lower is associated with youth. So, yep, youth wasted on the young. Okay, notice these two folks here in their mid, you know, low to mid 70s. They have low numbers. They must be doing something right. I'll bet they're anti-agers like a lot of us. They're taking their, you know, exercise, nutrition, metformin. This guy here, 44 years of age, it's closer to this, to these 70-year-old folks. Looks like a sick puppy to me. I bet this person has comorbidities, at least diabetes, probably heart disease, you know, a lot of other things going on. Now, this is not a scientific study. You real scientists out there, I know, it's just a pilot. It's a proof of concept that proves what? It proves that the data file I got with different ages that I could run these coefficients according to the way Lahallier and Weiss-Corey did it, and come up with a chart that's, yeah, it looks like there's a curve. You can apply some statistics or do what you want to. In my humble estimation, I would not hesitate to use this in my own self-directed age management program. Here's how. Not a scientific study. Most of the stuff I do is not, it's N=1 stuff, not pure science. But everything I do, I measure something. And part of my method is I measure multiple measures. I do a therapy, and then I look for shifts in hopefully all, if not almost all, towards youth. Greater grip strength, lower C-reactive protein, higher, longer amount of time that I can stand on one leg. Faster trail making B tests associated with youth. Better, faster measures associated with human benchmark mental tests. So what I would do and plan to do is that I would run this test on myself and others, plus I would send in unnamed, blind, no names, no identifying information, no ages, nothing, as replicates to informally validate. And I know there are all kinds of validation, but informally validate that measures are, duplicated, and do a therapy, and then look for a younger number associated with youth according to this protein clock profile. So I wasn't going to go into all that, but you started talking about clocks and stuff. There are some, well, it isn't as simple as going down and doing a LabCorp lab test. Each of these tests is like, the best price I could get is like $700 each. So for before and after, that's twice that. Plus the minimum lot down from 44 that they would run would be 15. And they're kind of doing us a favor to do that. Plus there are some, it isn't just a simple blood draw. There's some post-draw processing where you have to have a special kind of centrifuge, and talented phlebotomists can do this. It's not a real big deal, but it's they have to spin it down in a special high-speed centrifuge, and then immediately put it on dry ice, ship it overnight, things like that. So there are some obstacles, which is why I haven't actually released this into the wild yet, but it's one of many things in the many priorities of things I'm working on that's in the queue for sure. And this is high value stuff. So and actually, if any real scientists out there want to take on the task of working with me and statistically, after you read Lahallier and Weiss-Corey's paper, see what they did. If they did it right, they're real scientists. But if you want to work together and carry it, a step farther, I'd be happy to work with you. So there you have it. Questions, anyone?
Johnny, I just wanted to say I love your spreadsheet with that age calculation, or the age differential calculation. Thanks for that.
Phenotypic Age.
Online, the online. I'm starting to think that all your work is actually getting to the point where you can sort of franchise it.
Well, let me tell you where I'm coming from. Yeah, I like money as much as the next guy, but that was a great entrance for what I think everyone in this room will agree with, surely. Well, some of you are pure scientists, and your interest shifts more towards science than the end result. But I'm about the end results. And high achieving people tell us we need goals, and they need to be specific with dates. So mark your calendar, everyone. I want you at my big birthday party. I'll be 100, December 17th, 2049. Mark your calendar. And that's where we will continue the long-term planning. Life is just so damn interesting, and it's not about like being decrepit and infirm in some wheelchair. It's about youthful, vibrant life where we're living it to the max. So having said that, these things that I'm working on are either for myself or to facilitate scientists, specifically developing the creation of innovative therapies that will have the end result of getting us a lot more healthy years. Ideally, why not? Why not shoot for the moon? Why shoot small? Shoot high. The moon, then Mars, then beyond. Open-ended, healthy, joyful lifespan. And this isn't just a self-indulgent thing I'm talking about. After that, okay, we got a world to save out there. There's water for people who need it in the world, terrible, drought conditions and terrible water pollution, food for the famine stricken, social justice and equality for all, life, liberty, pursuit of happiness and facilitating that for everyone, education, freedom of choice, the list of things we need to fix in the world goes on and on. So this isn't just, some self-indulgent thing, but it's kind of like, when the plane's going down, and let's face it, our planes are going down, all of us here, whatever age you are, like they tell us, you put the oxygen on yourself first, and then you help everybody else. So it's kind of like that. So I don't know I don't remember what the question was, Miles, but it seemed a hell of an answer. Oh, franchising it. Franchise it. I don't know. It's like my aging intervention program, my plan to get a great many more years of healthy living, maybe open-ended, maybe as many as we choose. The thing I do for GRG, it's like, and then this stuff, it's kind of like gifts to the world, but and if you can think of a way to make money on it, I don't want any of it. I want to fund aging intervention therapy research. Tell me what the plan is. We'll do it.
Okay. Now I was just thinking something like a franchise to fund the institute, your foundation, to fund your foundation, or alternatively a zero-cost franchise. But I'm thinking of the package, the way that franchises work. In terms of getting agreements with, for example, doctors or medical hospital groups and so forth. I can't see the negative in that. But okay, I think we're going to talk about funding now.
Okay. Well, I mean, a little, Miles initially proposed that, and thank you, for getting this going. When you speak of funding, what specific, I mean, that's a real broad subject. What did you, any facet of it that you had in mind?
Yeah, no, like I said, I went to various doctors. Spoke to two doctors, one professor and an actual company that does clinical trials in association with various universities and with corporations in South Africa, here in Cape Town. And they said, yes, they can do this, not a problem, but normally this starts with a funding discussion. So I was not sure. GRG interacts with various corporations. Have any of them asked you to run clinical trials or to fund clinical trials, almost like a kind of a gathering point? Yeah, this is a question because if that is the case, and you do have access to companies that want to run clinical trials, then we've solved the problem if they can fund it. Like I said, I've got companies that are actually doing clinical trials here at tuberculosis and HIV. They can certainly take on more, and they would like to take on more.
Well, to answer your question, Miles, no, companies have not directly approached me to do clinical trials. Typically, if they were to, I would expect, not having been through it before, but it would be for a therapy to treat a particular disease and not so much to to solve the multifaceted underlying mechanisms of aging, which would in turn provide rewards and reduced risk for multiple diseases. I will say, though, that here in Florida, you know, having basically moved here, we have an apartment. I still maintain the California residence, and, you know, I'm still evaluating whether being here is the best use of my time. But after a number of months, I still am. So I must believe it is. We have, well, okay, there's one thing that you may or may not know of. It's called the Vitality and Aging Clinical Trial. I initially helped with it about 1.5 years ago when it in its inception and signed up as a subject. It's rather slow moving, and I don't really want to go into that any further, but you may go to the Age Reversal Network site and consider learning about it and signing up for it and deciding for yourself whether it would be worth your interest. But here's another thing I haven't talked about yet. I am the manager of an innovative, this is actually a company, it's a startup though, right from ground zero, Age Management Telehealth Physicians. And as the name implies, it is a telemedicine, telehealth organization with age management physicians that will visit with and treat patients remotely through visits, through technology, similar to what we're doing here. Although we've spent several weeks screening various systems and evaluating what we really need. And after evaluating lots of systems, having a lot of demos, I'm sick of demos. But anyway, we've narrowed it down to 2 that would fit our needs, and we're in the process of implementing them. I've been dusting off my software development skills lately, as there will be software implementation with these systems. So I would likely be the one to do that in addition to managing everything else. So anyway, watch for more information about that. It should be, you know, a method. I mean, one of the complaints I've heard from people in different areas is that it's difficult to find a age management, or if you want to call it an anti-aging doctor, I don't call it anti-aging, but age management physician in their area, that it's difficult. So this would help solve that problem. So look for more information, and that's something I've been spending a lot of time on.
That's actually very interesting, Johnny. That would be nice, because you could almost do a kind of consulting business on top of that.
How so?
You could be managing, having clients, but then using your app, so that you've got clients that are following your app, being told how to use the app, because you need a process of education. You need them to get their tests done. This is not, for us, I suppose it's easy to see, but a lot of people wouldn't know what to do to start managing their aging. So it's almost like a wellness clinic type thing, gerontology wellness clinic. That's quite an interesting idea, actually.
Well, yeah, thanks for that. There are, having to do with this, various regulatory and regulatory compliance aspects. but that's something I hadn't really thought of, to kind of have those two working side by side or piggybacking. And basically, this is something that, oh, Eugene's coming in. Fantastic. This is something that, that I have a lot of latitude in the design. And I'll just, roll back a little bit. My way of doing things has been small studies among groups of associates, like small pilot studies, you might call them, proof of concept, informal studies, and even in myself, and n equals 1, n equals me, as I call it, or if it's you, it's n equals you, where as a group together, we take biomarkers, and in that aging intervention program, part 4 lists everything I know about them. And we do the biomarkers. We have a core set of markers like the CBC metabolic panel plus CRP, which we pump into the Levine-Kramer phenotypic age calculation. And then some others, mental tests, physical tests, and some others depending on the therapy. And do the therapy and then look for shifts towards youth. With me, everything I do, I measure in some way for simple, nutritional supplement or nutraceutical things, like one called plasmalogen by a company Prodrome. But that was a design over a 15-year period by a high-level member of our community, Dayan Goodenow. He's made some very useful posts to our group recently, but be that as it may, this prodrome, the tests I do for a simple test, rather than getting fancy with a lot of blood tests and DNA methylation and all that, it's 2 mental measures and 1 physical measure. The mental measures are the trail making B test, and all that's in the document, the aging intervention program I told you about. It's how fast you can connect numbers and letters. And also the human benchmark at humanbenchmark.com. It's different number memory, word memory, different types of tests. So that's the mental measures, plus the physical measure I usually use is on an elliptical machine, which is also described in the program. 3 sets of high intensity 20-second bursts separated by just relaxation and, calm down. And then how many I can pump out in those 20 seconds. So it's just pushing the limit in stamina. So, and I received some outstanding results on the prodrome plasmalogen, but that is the informal test I use for like nutraceuticals. So how did I get there? Oh yeah, I was talking about just the small studies 3 or 4 of us do, like we did with the dasatinib plus quercetin. We did that with exosomes. And what I do with different things, what one of our guys did with GCSF, so forth. So that's related to your question, Miles, but that's my backyard.
I'm very interested in your the age management telemed network. Since COVID started, there's been like an explosion of telemed, and including some sort of national launches of services that are, lining up doctors that will do telemed remotely all over the country.
Yeah.
And I've looked at them. I've considered joining them, but I've actually been searching for doctors who really specialize in what we're looking for, which is someone that understands what we're trying to do versus just like, you know, the more typical either just conventional medicine or you know, the naturopath doctors that are somewhat overlap but not always, you know, you're finding the right doctors. I mean, for example, on GRG, there was a fairly lengthy thread that went on for quite a while on how to get doctors to prescribe metformin. Yeah. So, and you know, and a lot of people say, "Oh, my doctor did it," but then 3 or 4 people, I tried every doctor in town and couldn't get one to do it. So,
yep. Well, this will solve that problem. If you can hold on a while, you'll be on the everyone on GRG will be on the A list. But Sajjad Zalzala with, I think it's called Ageless RX, but you can find him, you'll find the company, SAJADZALZALA. He is doing this now. He prescribes metformin, and you may or may not, you know, want to consider signing up for him.
Well, I mean, he's you know, he's basically selling the metformin too, and it's quite expensive through his sourcing. If you
really?
I mean, I was getting mine. We get ours from Russia at probably 5% of the cost, or 5 or 10% of the cost, and if you can get a friendly doctor to do it, your insurance might cover it, and it's a very inexpensive drug. It's over the counter most places in the world except here. So, and because, you know, so a lot of people said, well, when I travel, I bring home some, but you can't travel anymore, at least for the time being.
Right. Well, yeah, I get it. Medicare covers it. Cheap. Yeah. But anyone who wants metformin, contact me, please. Okay?
Okay.
John Wenger's hand is up, Johnny.
Whose hand?
John Wenger.
John.
Yeah, I like several things. I like the data scraping work you're doing. That's worth continuing. I like Miles' idea about the wellness center, and I like the recent comments of Jeff Parker. And I'll just make a comment too with regard to the HIPAA laws, the privacy laws.
Yeah.
They protect us from institutions releasing our private data to the world. However, Johnny, I own my data too, and I'm happy to say that I just was at the doctor the other day, and my blood pressure, which has been high, was 125/80 in the doctor's office. Now, when I was maybe 25, I would get those kind of numbers in the doctor's office. But by the time I got to be 40 or so, my blood pressure started creeping up into the 140s, you know, and there've been plenty of times when my blood pressure within the last year or two was something like, you know, 170/110 in the doctor's office. So 125/80 is something I'm happy to shout to the world. You know, some of the things, diet, whatever, maybe it's just a random event, you know, maybe it was the focus of neutrinos hitting my brain over at UCLA Health. I don't know what it was, but it's a result that I'm happy to share with. I'm not afraid of saying that I had low blood pressure last Tuesday. So we're all free to give up our data to if we choose to. And so that's the workaround with regard to the HIPAA laws. They protect us from institutions, not from sharing our own data with a joint project, whether it be GRG or any of the others that have been mentioned. So that's really, those are the comments that I wanted to make. I'm interested in your thoughts on that, everybody's thoughts on that.
Well, to my understanding, we are free to release our data to who we choose, but it requires our okay.
Yeah, and beyond that, I mean, it's one thing to share share my blood pressure with the people in this group here right now, and to anybody who would be checking the archive. But it's also possible for me to, for example, take my, release my data in a private form, say something like Mr. X in the Los Angeles area had a low blood pressure on Tuesday, you know, and that, you know, I mean, the NSA has our data, the CIA has our data, the Russians have our data, the Chinese have our data, all the big corporations have our data, Bill Gates has our data.
They're probably listening right now.
Absolutely, they're listening right now. And but the fact is, if you have some data that you're embarrassed to report, well, you know, the point is, if you report your data with your identity redacted, but maybe not your statistics, like you know, I'm 6'1", you know, 185 pounds, you know, that kind of stuff. And name redacted, has low blood pressure on Tuesday. I'm happy to share that data to the world.
Yeah. Well, Eugene, long time no talk. I made a mental note to contact you. You've been too quiet lately. How are you? Well, what are you working on?
Very good. But I was just under the impression we're supposed to start at 2 p.m. Pacific time, but I see you already just at full thrust here.
Yeah, 2 p.m. Eastern, 11 Pacific.
Well, just, you know, as you're aware, just we lost our colleagues, oncologists. Now I kind of just bringing pieces together, bringing just the other oncologists from Russia. I'm working on that. Just I have already a company, so working just for new logistics, because we already just wanted to start pilot clinical trial. Just on no option cancer patients, but now just things we lost the main guy, so now just I'd rather to still just get back to preclinical just models, so we'll just have to be sure that actually safe and just efficient, so we'll proceed with that. But of course this is I don't know, maybe not everybody knows, this is only one part of just equation, because the second part is involved just radical anti-aging. It's absolutely, I don't know whether just you're aware of this, about this papers recently published on these ideas. It's very just groundbreaking, but we still have to take step back to kind of to restructure everything and still move forward. This is related to the project what just we were contemplating for a long time. And this meantime, I really just want to do this also plasma things, but I would do just because I believe just by one component itself, it would not work well. Because if you get rid of just aging milieu or old aging signaling, it's not enough. So I believe you need to do like, after a while, you have to do like maybe stem cells or exosomes. That would definitely just would be best option. So, and probably I'll be just testing this on myself and a couple colleagues who wants to do the same as soon as like all this traveling restriction will be just lifted. So this is my short plans, and of course I'll do this with all these big panel markers, like maybe 50 of them. So that's actually this a little bit different, but it's kind of near term direction what we'll be just going to, if in brief.
All righty, so glad to hear it's still progressing.
Yep. So to my understanding, today meeting was mainly just about partial epigenetic rejuvenation. So somebody will take lead on that. So how?
Well, we had a number of topics that we worked through. Let's see.
Okay. So hopefully I wasn't late for the meeting, because I was under pressure that start just at 2.
Yeah, sorry. Yeah.
You might
Eastern, 11 Pacific.
This is being recorded, right? So if Eugene, you wanted to listen to what was said, you know, it's recorded. Is that right, Johnny?
Yes.
Okay, all right.
So let's see. All righty.
So
I'm
what
all
is it?
talked out. Thanks for listening to me talk so much.
Okay, so it's already practically finished. Yeah, you already just had this talk for a long time, right? To my
Yeah.
understanding.
Sorry.
Oh, really? No, I didn't realize that I supposed to just started like 2 p.m. Pacific. So, but anyway, then it looked like I missed the whole conversation then.
Yeah.
It's okay.
Well, okay. I guess unless anyone has something else, we'll call it a day.
All right. Okay.
Thanks. That was fun.
Okay.
All right.
Okay. Thank you, everybody.
See you
Bye-bye.
next time.
Thank you. Thank you, Johnny. Thank you, everybody. Bye-bye.
Thank you, Johnny.
Bye, and thank you, Miles. You're the driving force behind this. Great.
I see we had 20 people this time. Last time was 22 and the first time also 22. So not much difference.
Very
Thank you.
Bye.
Thank you, Johnny. Thank you, Miles. Very
Bye.
informative. Bye-bye.
Thank you.
Bye, everyone.